All right, so you've already read through the exponent laws that you've learned up until this point. So I thought I'd go through and write a few of the rules down so that they're a little bit easier to see. So right now, here we have 2 to the negative 3. It says rewrite as a positive power, then evaluate and express in a rational form. So this becomes 1 over 2 to the power of 3, since we want to change that negative exponent into a positive, and we end up with 1 over 8. Here, slightly different, we have a negative out in front. So that negative is going to stay out in front, but we're still going to flip our fraction the same way. So we end up with negative 1 over 8. You can put the negative in the middle, or you can put it on top. Here, we're going to have 1 over negative 2 all to the power of positive 3, because moving levels changes it. So we end up with 1 over negative 8, and normally in math we never leave the negative in the bottom. We're going to move it down. So in this example, we'll have negative 1 over. And again, we have 1 over 2 to the power of 3. Here, it's very tempting to take these two negatives and to put them through. However, we can't do that because of order of operation. So that negative is like a negative 1 over negative 2 to the power of 3. We get negative 1. Negative 2 all cubed is negative 8. And then finally, a negative divided by a negative gives us 1 over 8. Whoops, I noticed in letter D that I forgot to simplify to give us negative 1 over 8. In this example, we want to rewrite it. So again, we're testing your ability to change negative exponents into positive and recognize the placement of brackets. So we will have that negative on the outside stays there. Because we have a negative exponent, we can flip the fraction. So we end up with negative 3 over 2. I put the negative on top. It's just good practice. And then we have a 4. So again, that negative on the outside, we're going to end up with negative 3 to the power of 4 over 2 to the power of 4. So we have negative, and then it's going to be 81 over 2 to the power of 4 is 16. So our final answer is negative 81 over 16. Always check to see if something can be reduced, but in this case, it cannot be reduced. Here, simplify, evaluate, and express your answer in rational form. All right, so 3 to the negative 5 becomes 1 over 3 to the 5. Divide it by 3. There's an imaginary 1 that's written there. This becomes 3 to the negative 4. So I'm going to have 1 over 3 to the 5 divided by 1 over 3 to the negative 4, which is really 1 over 3 to the 5 multiplied by 3 to the negative 4 over 1, because when we're dividing fractions, we multiply. So I end up with 3 to the negative 4 over, oh wait, now do you see the mistake I made? This is not a negative, it's a positive by making that flip. So I'm going to have a plus here, a positive here, 3 to the 5. Then when we subtract, we get 3 to the negative 1 since our bases are the same. So our final answer is 1 over 3. Or probably a more efficient way would be 3 to the negative 5 divided by, if we simplify inside that bracket, we're going to get 3 to the negative 4. When we're dividing, we subtract exponents. So we end up with negative 5 plus 4. Either method is fine. So this example incorporates a bunch of the different rules that we have. Either one is fine. Then there's probably another method that you could use here. The only thing that you don't want to do is to actually evaluate and turn that 3 to the 5 into an actual value, or the 3 to the 4 as an actual value. You want to incorporate your rules. All right, our next example. So evaluate the expression below, no decimals. So this one is a bit different because we're not multiplying or dividing. We're going to have 1 over 4 squared. Subtract 4 to the power of 0 has a value of 1, since anything to the power of 0 is 1. So we get 1 over 16 minus 1. In order to subtract fractions, we need a common denominator, which in this case will be 16. So when we evaluate this expression, we end up with negative 15 over 16. Students really want to add those exponents together or to subtract them. However, you can only do that when you're multiplying and when you're dividing. Okay, so evaluate. So this is where we're going to substitute in. So it's giving us values for x, y, and n. So x is negative 1. So I have negative 1 to the power of negative 3 minus y, which is negative 2, again to the power of negative 3. They're all inside of a bracket to another value of n that's negative 3. There are multiple ways of doing this. The one thing you're not allowed to do is to actually multiply that negative 3 on the outside in because of the subtraction sign. That's preventing everything from happening. So I'm actually just going to evaluate the inside of the bracket. So I'm going to have, so when I flip this, 3 goes on the bottom, minus, same thing here, all to the negative 3. So I'm working inside right now. 1 over negative 1 minus 1 over negative 8. I'm going to clean that up a little bit. This is negative 1 plus 1 over 8. Since the negative and the negative make a positive, I'm going to go back because I forgot my exponent up here. So then I'm going to have negative 8 over 8 plus 1 over 8 all to the power of negative 3. I'm going to move over here. So then that's going to equal negative 7 over 8 all to the power of negative 3. To make that a positive, we're going to flip. So I have 8 over negative 7 cubed. So when I am evaluating, we are going to get a fairly large number because 8 squared is 64. And if we multiply 64 by 8 again, we're going to get 480. I believe it's 554. I don't have a calculator in front of me, so I can't check that. I know that I'm going to have a negative overall answer because I have a negative 7 that's cubed. 7 times 7 is 49, and if we multiply 49 by 7, we get 280 plus 7 times 9 is 63. So 280 plus 63 is 343. So I believe that's the final answer. That 544 on top I might be off slightly, but the whole idea is the process. This is as hard as it gets in terms of these questions because there's so many things involved. Lots of steps, which makes it a little bit more challenging. Actually, don't worry about this example. You're not going to see anything like that. All right, now rational exponents. This is something else that you've looked at. If you use your calculator and you input 25 to the power of 1/2, it's going to tell you that it's 5. You use negative 8 to the 1/3, you're going to get negative 2. And if you do negative 243 to the power of 1 over 5, you're going to get negative 3 as your answers. Now these are very nice answers. What do you notice about 25 to the half? It's 5. What else? How else do we come up with 5 if we have 25? Square root. This is the 5th root for the 243 question and the 3rd root for negative 8. So using that, we have the rational exponent laws. So if you have a denominator, that's going to be the root you're taking. If there's a value in the numerator, then that's what you're going to do to your overall answer. So as we just saw, this becomes the square root of 25, so our answer is 5. This one becomes the cubed root of negative 8, so we get negative 2. This becomes the 5th root of negative 243, which equals negative 3. Negative 16 to the 1 over 4. So we're going to take the 4th root of negative 16. If you try to do this, you're going to get an error. So this has no solution. It doesn't work. For this example, the denominator is 3. So we're taking the cube root of 27. And when I get that value, you have to square. So we end up with the cube root of 27 is 3. I need to square it. So the final answer here is 9. Over here we are going to have the fifth root of 32 all squared, and then the negative stays on the outside. The negative isn't on the inside, so we don't include it. So we're going to have negative bracket 2 squared. Once again, our order of operations tell us to do exponents first. So the final answer in that question is negative 4. Bracket placement really, really important. What if the values are negative? You have to do that initial step where you need to make your exponent positive, then everything else is the same. So in this example, we're going to have 1 over 16 to the 1 over 4, which is the same as 1 over the fourth root of 16, which is 1 over 2. If you do that on your calculator and you write the answer 0.5, you won't get credit for getting that question correct. Here again, it's 1 over 16 to the positive 3 over 4, which equals 1 over the fourth root of 16 all cubed, which is going to be 1 over 2 to the power of 3, which equals 1 over 8. In this example, I'm going to leave that negative up on top, and in the denominator, we're going to have 8 to the power of 2 over 3. I don't really need the bracket right now because there's no negative associated with the 8. So I have negative 1 over the cube root of 8 all squared. So we have negative 1 over 2 all squared, which equals negative 1 over 4. You can definitely use your calculator to check these answers to make sure they're right, but just make sure you have the fraction and the equivalent decimal if you're going to do that. So here I'm going to have negative 1 on the bottom. I'm going to have negative 27 to the power of 1 over 3. So we get negative 1 over the cube root of negative 27, and it's to the power of 1, so I don't need to actually show that. So negative 1 over negative 3 gives me a final value of 1 over 3. So the key with this one is don't forget about that 1 over. So it changes your answer slightly. All right, let's see what's next. So rewrite as a single positive power, then rewrite in a radical form. So that means turn it into a root if necessary. So here I have 8 to the 5 over 6 times 8 to the 1/2 over 8 to the 5 over 3. Mathematically, what we have here is 8 to the 5 over 6 plus 1 over 2 minus 5 over 3. The numerator we're multiplying, common basis, so we can add the exponents, and then the division we can subtract. So I need a common denominator, which is going to be 6. So I had 5 over 6 plus 3 over 6 minus 10 over 6. So we end up with 8 to the power of negative 1 over 3, which will give us 1 over 8 to the 1 over 3, which becomes 1 over the cubed root of 8, which equals 1 over 2. So again, take it step by step, work with the rules that you know, and then it'll simplify. In this example, I'm multiplying that 10 to the negative 4 times 10 to the 1 over 5. So I'm actually going to go ahead and turn that into one base. So that's going to give me 10 to the negative 3 over 5 divided by, this is 10 to the power of 2 over 3. So I turned it into that fraction form so that I could evaluate. Next, because it's division, I'm subtracting those exponents. So again, common denominator, which will be 15 in this case. So I need to multiply that negative 3 over 5 by 3. So I get negative 9 over 15 minus 10 over 15. So this is going to equal 10 to the negative 19 over 15, which equals 1 over 10 to the negative 19 over 15. This is a positive now since we flipped it. So this is an ugly value. 15, 10, all to the 19. Seems ugly. I'm just going to go back and recheck my math to make sure that I got everything right here. The negative 4, 5 plus that, so negative 4 plus 1 is 3. I don't see any errors. If you're watching this video and you come across something that you think is incorrect, please let me know because we all make mistakes. It's very easy to make mistakes. So that's a sort of, it's a short summary of some of the examples of your general rules that we have.